Kia ora Year 11 and any Year 12s who are redoing AS and Year 10s. This is a question for Ben from the end of the November 2017 Pure 1 paper, paper 13 or 1-3. There are 3 parts to it. The first 2 parts are really easy and the third part needs a wee bit of thinking. And I'm going to do the third part in 2 different ways. I think one of them will be pretty obvious when I do it and the other one might make you look at the problem slightly differently. So the first thing we've got is we've got a curve and we've got 2 points on that curve. So point A and point B. First up, we have to find the equation of the line AB, and we give our answer in the usual form. So the gradient of that line will be m. So m is equal to the change in y over the change in x, which will be 2 minus 0 over 5 minus 1, which gives me a gradient of 1/2. So we know the line will be y equals 1/2 x plus c. Now I'm going to sub in one of those points. I chose to sub in A because it's got a 0 in it. So 0 is equal to 1/2 times 1 plus c. So c is equal to negative 1/2. And that gives me the equation of that straight line as y equals 1/2 x minus 1/2. Okay, and now the second part of the question says, showing all necessary working, find the equation of the tangent to the curve, which is parallel to AB. That means that we want to find the derivative, and then we're going to set that derivative equal to 1/2. And I'm going to draw in what we're looking for now. Now, you can't always rely on diagrams in Cambridge exams or any other exams being to scale, but in this case, this diagram actually is to scale, and we can see what the answer is going to be that we get, right? So take your ruler, the line that we want, the tangent is going to be parallel to that. So just slide it out to here. And actually doing it in OneNote, you can also see the angle of that, the angle being formed there at 26 degrees. So I'm not going to use that in the last question, but there is another way where we can use that angle. All right, so what we're looking for is this equation of the tangent line. So the first step is to say, well, y is equal to x minus 1 to the power of 1/2. dy by dx is equal to 1/2 of x minus 1 to the negative 1/2. And we want that to be equal to 1/2. So 1 over 2 root x minus 1 is equal to 1/2. I can times both sides through by 2, and that will give me x minus 1, root x minus 1 is equal to 1. Right, so I'm cross multiplying in there as well. Squaring both sides gives me x minus 1 is equal to 1. So x is equal to 2. And then y is equal to the square root of 2 minus 1, which is the square root of 1, which is 1. So what I'm doing in here is I'm finding this point here. So I'm finding the point where the gradient of the tangent will be equal to 1/2. The reason I'm doing that is I need a point to anchor in my straight line equation, right? So step 1 is to figure out where is the gradient 1/2, and it's here. And that means that we know that the tangent equation is going to be this, and we know that 2, 1 is on the tangent. So 1 is equal to 1/2 times 2 plus c. 1 is equal to 1 plus c. C is equal to 0. So the tangent equation is simply y is equal to 1/2 x. Right, so we've got 2 straight line equations now. This one here is just the one between A and B, and this one down here is the tangent. What we need to do next is to figure out what's the distance between these two. Right, so I can choose anywhere along here because those 2 lines are parallel, and I'm looking to find that distance d. So there are a couple of ways to do this. I'm going to do, the first thing that I'm going to do is the way that I think is less obvious, and I think probably most of you won't like this way, but I'm going to do it anyway. I'm just going to go onto a new page with a spare graph. Right, so let's just make this graph a wee bit bigger. We are looking for a distance between 2 parallel lines. So I'm going to draw in the tangent. I'm going to draw this line in a bit more, the AB line. And I'm also going to draw in the tangent line, which is going through here. And hopefully what you're going to notice is, well, I'm going to extend that axis down like this. Now, hopefully some of you will notice that we've got a little triangle here. Let's make that point C. So the area of that triangle is equal to 1/2 of that rectangle. So it's a half of 1, this distance here, and this intercept here is at -1/2. So it's a half times 1 times a half. So we know that this little triangle is half of that rectangle. Right, so I'm going to go really slowly with this. So there's the other half of the rectangle. Right, so they match up. And the rectangle area is very easy to find. It's 1 times 1/2. So that area of that triangle will just be 1/4. Now let's turn that triangle around and see what are we looking for. So I'm going to get rid of all of this mess, except not the line. Thanks for your patience, guys, if anyone's still out there. I keep undoing the lines instead of putting them in. There we are. So here's my line here. Now, what I want to do is to find this distance here. So we're looking for distance D. Right, so what's distance D going to be? Well, we know that the area is 1/4, and that's also equal to half the base times the height, and the height that we want is our letter D. So what I need to do now is find out what that base of that triangle is. This point here is -1/2, 0, and this point here is 1, 0, and I called this point C before. So we're going to find the base, which is the distance between A and C. Right, so C is -1/2 and 0, and A is, no, that's not right, C is 0, -1/2, and A is 1, 0. So AC is 1 minus 0 squared plus 0 minus -1/2 squared. That gives me the square root of 1 squared, which is 1, plus 1/4, which is the square root of 5/4, which is √5/2. So we know this 1/4 from the easy rectangle calculation, and now we've figured out what the base is. So we can say that 1/4 is equal to 1/2 times √5/2 times D. So 1 is equal to, so I'm multiplying everything through by 4, 1 is equal to √5D, which gives me the distance as 1/√5. And I'm asked to do that here to 2 decimal places. So when you chuck that in your calculator, what did I get? I got D is equal to 0.45 to 2 dp. So as I said, I think that way was probably quite an unusual way for people to do it. It is mentioned in the examiner's report. And now I'm going to show you the way that I think most students will have done this. But I want you thinking about triangles when you see questions like this, because you never know when you're going to come across a problem where you have to use an approach like that one there. Okay, so looking at it again now, I think the easier approach for most AS students is going to be to say, well, we know this point here is 2, 1. And we know the gradient of that line, the purple line, is got a gradient of 1/2. That means that what I'm looking for is this distance D here. And the distance D here is the distance between this point here and this point here. So what I need to do is to find the line perpendicular to the purple one, which is not difficult to do, that goes through the point 2, 1. Okay, so M tangent is equal to 1/2. So the perpendicular M is equal to -2, because we have M1 times M2 is equal to -1, right? Perpendicular gradients multiply to give me -1. And we know that the point 2, 1 is on the line. Right, so we're drawing a nice diagram here, and we're saying what is that point? We'll call it capital D. So the equation is going to be y equals negative 2x plus c. 1 is equal to negative 4 plus c, giving me c is equal to 5. So that line that we want has equation negative 2x plus 5. Let's draw that on and just see if that looks about right. Yeah, well, you can see that it absolutely looks right because the y-intercept is really, really high. And it's going off up there. Okay, so what's left now is to say, well, this line here is y equals 1/2 x minus 1/2. And this line here is y equals negative 2x plus 5. So point D is where they intersect. So negative 2x plus 5 is equal to, what was the other one? 1/2 x minus 1/2. That gives me negative 5 over 2x is equal to negative 11 over 2. So x is equal to 11 over 5. And the y value here, well, we can get the y value from either of these. But the y value will be 11 over 5 times 1/2 minus 1/2, which is 11 tenths minus 5 tenths. 6 tenths or 3/5. So point D is equal to the point 11/5, 3/5. And we need to find the distance between D and 2, 1, right? So we've got that coordinate there now, and we've got this. So the distance between the two curves will be the distance between these 2 points. So D is equal to the change in the x coordinates and squared plus the change in the y coordinates squared, which is equal to the square root of 11/5 minus 10/5. So that gives me 1/5 squared. And here we've got 2/5 squared. So I'm going very slowly through this because I don't want anyone making mistakes right at the end. 1/25 plus 4/25. So Ben, I hope you're still watching, but I bet you're not because you probably figured this out once I started talking about it. Right, there's 5/25, and that's 1/5 there. And so you see, obviously, it's good that we get the same answer, right? So D is equal to 1 over root 5, which is equal to 0.45 to 2 dp. Okay, and there were a couple more ways, again, that we could have done, but you can look those ones up in the mark schedule. So Zach, sorry, Ben, I hope this has helped. Just keep on sending in any tricky questions that you guys are finding.